We're talking about selections, and I'll go through a demonstration. At its most basic, we have this variable a that we create, and we assign it the value 2 equals 3. And what the equal does is it truly checks if it's equal. Again, a single equal sign is an assignment. The double equals check to see if it's so. So is 2 equal to 3? And let's run that. And we can see that the value of a, when I'm looking down at the workspace, the value of a is 0. So that's saying that it's not true. So this gives you this equal, or down below we're going to look at less than or equal to, that sort of thing. Those decide whether they're true or not. If they're not true, it's a 0. If it is true, then it's a 1. So we can look, and if I change this to 3, for example, does 3 equal 3? Now a equals 1 because it is true. We can work with this vectors. So I create 2 vectors, B and C, and you can see what they are. Now I'm going to have a variable D, and I'm going to ask, is B equal to C? And if I run that, I get a vector. The result is a vector. And if I look at it, actually, it'll probably be easier to look at it this way. Let's run it again. If I run that, I can see that the vector D is 0, 0, 1. That's because 2 is not equal to 4. That's a 0. 5 is not equal to 4. That's a 0. 6 equal to 6. That's true, so that's a 1. So I just created a new vector, same number of elements, and it gives me 0s and 1s. We can also less than, greater than. If I run this, I have a variable e, and I'm going to ask, is 6 greater than 6? And here is the value of e. It might be easier for you to look at it this way. Let me run it again. E equals 0 because 6 is not equal to 6. Now I can change this, and I can put an equal sign in there. And is 6 greater than or equal to 6? And I run it, and now e turns to 1. We can work with strings also. So variable f, and it says the string below hello, is it equal to the string hello? And this is interesting what happens. If I run this, I get a vector f, and it's true, 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 true. And what it's doing is it's looking at each character one by one, and it's saying yes, the h is equal to the h, the e is equal to the e, and so on. So let's change this just a little bit. I'll put in whatever. So I'll say, is hepo equal to hello? And you can take a minute and predict. And you can see that it found that the p's were not equal to the l's in the middle. Here we have a typical decision structure, and it uses the logic we just demonstrated. It uses the logic to figure out what to do, whether to select something. So here we have G equals 6, and this is the format of it. If G is if something, then something happens. You don't have to say then, or it just, you put it in the line below, and then you have an end. So if G is less than 10, then H equals G plus 5. And we start off with G equals 6. You have to have the initial in there. And if we run it, we can say, see, let me uncomment this. Let's run it again. So we have G equals 6, and because it is less than 10, then H equals 11. And just to verify that, we'll uncomment this, run it, and now we have I, which is G plus H, is equal to 17. Run it again. I is equal to 17. Thank you.